Okay, so now I will be going over question 7. So the first important concept in question 7 is momentum. Okay, so the definition of momentum is the quantity of motion of a moving body. And we express momentum as P is equal to m times v, where m is the mass and v is the velocity. So that is the value that we express for momentum. Okay, so now if momentum changes, it will only change due to velocity. And velocity will change due to, or changes in velocity is due to, or is acceleration. And so acceleration is caused by a force. So when we change momentum, it's by a force. So we express change in momentum or change in P as force times time. And this is often referred to as impulse. And so impulse is equal to force times time. Another way to look at that is force is equal to the change in momentum with respect to the change in time, or just the mv final minus mv initial. So change in momentum is due to a force, and that is the only way to change momentum, because acceleration is caused by a force, and changes in velocity is caused by acceleration, or is acceleration. Okay, so the next concept I will go over is kinetic energy. So I've already explained this in other videos, so I'll just do a more quicker explanation. But basically, the formula for kinetic energy is 1/2 mv squared, where m is mass and v is velocity. And so if kinetic energy changes, momentum will also change. So, and it's proportional. So if momentum increases, kinetic energy will increase. Momentum decreases, kinetic energy will decrease. And that's because this is 1/2 mv squared, and then for momentum, the equation is m times v. So they both have velocity, so it's a proportional relationship. If one increases, the other will as well. Okay, so now I'm going to read question 7. 2 carts of equal mass are on a horizontal surface with negligible friction. Cart A is approaching cart B, which is at rest, as shown in figure 1 above. Attached to cart B is a spring that is initially compressed. At the moment cart A collides with cart B, the spring is released and pushes on cart A, as shown in figure 2 above. Which of the following correctly states what happens to the kinetic energy and the momentum of the 2-cart system as a result of the collision compared to those quantities before the collision? Okay, so basically what's happening is cart A is moving towards cart B, and then it gets compressed by the spring, and then a force is causing it to move the opposite direction. So we're trying to look at what happens to momentum and what happens to kinetic energy. So in this problem, as it states here, the spring is released and pushes on cart A. That means that a force is occurring on cart A. So since a force is occurring, momentum will change. And since it's being compressed and then released, the momentum will increase. So we can write momentum will increase because, as you can see from this problem, there is a change in momentum because a force is happening, and so that is causing the momentum to go up because it's being compressed by the spring and then released, and that's causing momentum to increase. Okay, and as I've stated before here, So we're also looking at kinetic energy. If momentum increases, then kinetic energy will also increase. So I can also determine from the problem that kinetic energy will also increase. And that's because momentum increases and they're proportional. So in conclusion, so that means that the correct answer is C, which shows kinetic energy increases and magnitude of momentum also increases. So as I've shown, or in conclusion, in this problem, I explained important concepts of momentum and how a change in momentum is caused by a force. Change in momentum is equal to a force times time. Change in momentum can also be called impulse, and so that's important for knowing what causes a change in momentum. And then I also explained important concepts of how kinetic energy is related to momentum through velocity, and both of their equations have velocity in them, so they are proportional to each other.